Scientists just discovered galaxies that shouldn't exist. They formed before the universe had enough time to create them. And if you think that's mind-blowing, wait until you hear what else the James Webb Space Telescope found in just 2 years of operation. If you clicked on this video, you already sense that something massive is happening in astronomy right now. You're absolutely right. And what you're about to learn will fundamentally change how you see your place in the universe. These aren't just pretty pictures or abstract concepts. Every discovery I'm about to share directly impacts our understanding of existence itself. Whether there's life out there, how the universe actually began, and why everything you learned in school about space might be wrong. Let's start with the discovery that has cosmologists losing sleep. JWST found massive, fully formed galaxies existing just 300 million years after the Big Bang. That's like finding a fully grown oak tree in a pot where you planted the seed yesterday. The galaxy Glass Z12 shouldn't exist according to our models. It's too big, too bright, and too structured for its age. Here's why this matters to you. If galaxies formed faster than we thought possible, it means the universe operates under rules we don't fully understand yet. The Lambda CDM model, our standard model of cosmology, can't explain these ancient giants. Some scientists are not questioning if the Big Bang happened the way we think it did. Others suggest time itself might work differently in the early universe. But JWST didn't stop there. It found 6 more impossible galaxies. CEERS 93316 formed when the universe was only 250 million years old. It has the mass of 1 billion suns. The mathematical models say it needs at least 1 billion years to form. It did it in a quarter of that time. This isn't a small discrepancy. This is like physics throwing up its hands and saying, "I quit." The practical implication is staggering. If matter can organize itself faster than we thought possible, it changes everything about how we search for life. Complex structures forming quickly means the window for life to emerge might be much larger than we assumed. Speaking of life, let's talk about the discovery that made headlines worldwide. JWST detected methane and carbon dioxide in the atmosphere of K2-18b, a planet 124 light-years away. But here's what most reports missed. The ratio of these gases suggests active biological processes. On Earth, that specific combination only happens one way: life. This isn't speculation. The data shows dimethyl sulfide, a molecule only produced by living organisms on Earth. Phytoplankton in our oceans pump out tons of it. Finding it on another world is like finding a fingerprint at a crime scene. Something alive might be there right now, breathing, metabolizing, existing. But the real shock isn't finding one potentially habitable world. JWST has shown us that the building blocks of life are everywhere. Water, methane, carbon dioxide, and complex organic molecules appear in places we thought were barren. The Orion Nebula alone contains enough alcohol molecules to make 400 trillion pints of beer. That's not a joke. That's real data showing organic chemistry happens naturally throughout space. Every time JWST points at a protoplanetary disk, it finds the ingredients for life. The TRAPPIST-1 system has 7 Earth-sized planets. JWST confirmed at least 3 have atmospheres. The odds of finding life went from astronomical to probable. We're not asking if life exists anymore, we're asking where to look first. Now let's talk about something that broke physics so badly, scientists are still arguing about it. JWST found supermassive black holes in the early universe that are way too big for their age. The black hole in galaxy Sears 1019 has 10 million times the mass of our Sun. It formed just 570 million years after the Big Bang. That's physically impossible according to our models. Here's the problem. Black holes grow by eating matter, but matter can only fall in so fast. It's called the Eddington limit. Push past it, and radiation pressure blows the incoming matter away. The black hole stops growing. To reach the sizes JWST is seeing, these black holes would need to eat faster than physics allows. The solution might be even stranger than the problem. These black holes might have formed from collapsing gas clouds the size of entire star clusters. Skip the star phase entirely. Go straight from gas to black hole. It's like nature found a cheat code for making supermassive black holes. This discovery rewrites our understanding of how galaxies form. Every galaxy has a supermassive black hole at its center. If these form differently than we thought, then galaxies did too. The chicken and egg problem of which came first might have a completely different answer. But the most mind-bending discovery involves the first stars ever born. JWST detected chemical signatures from population 3 stars. These cosmic monsters were 300 times more massive than our sun. They burned so hot and bright, they lived for only a few million years before exploding. Why should you care about stars that died 13 billion years ago? Because every element heavier than hydrogen and helium in your body came from inside these primordial giants. The calcium in your bones, the iron in your blood, the carbon in your DNA, all of it was forged in the nuclear furnaces of these primordial giants. JWST showed us these stars were more common than we thought. They didn't just sprinkle a few heavy elements around, they seeded the universe with the stuff of life. Without them, rocky planets couldn't exist. Chemistry as we know it would be impossible. You wouldn't be here reading this. The telescope also revealed something disturbing about dark matter. By measuring gravitational lensing around galaxy clusters, JWST found structures that shouldn't exist if dark matter behaves the way we think it does. The galaxy cluster SMACS 0723 bends light in patterns that don't match our dark matter models. Some scientists now think dark matter might not be a particle at all. It could be primordial black holes, tiny ones, smaller than atoms left over from the Big Bang. Others suggest our theory of gravity needs modification. Either way, 85% of the universe's matter remains a complete mystery, and JWST just made it more mysterious. But here's the discovery that has cosmologists genuinely worried. JWST confirmed the universe is expanding faster than it should be. Hubble spotted this problem years ago. Scientists hoped it was measurement error. JWST killed that hope. The universe expands at different rates depending on how you measure it. Nearby galaxies move away from us at 73 kilometers per second per megaparsec. But when we calculate expansion using the cosmic microwave's background, we get 67. That difference might sound small. It's not. It's like measuring your height and getting two different answers depending on which ruler you use. This crisis in cosmology suggests something fundamentally is wrong with our understanding of the universe. Dark energy might not be constant. Space itself might have properties we don't understand. New physics is required, and nobody knows what it looks like yet. The implications are staggering. If the expansion rate is wrong, so is the age of the universe. So is its ultimate fate. Will it expand forever, collapse back on itself, rip apart at the atomic level? JWST showed us we don't know. But perhaps the most profound discovery is the sheer number of galaxies. JWST revealed the universe contains at least 2 trillion galaxies. That's 10 times more than we thought. Each galaxy contains hundreds of billions of stars. Most stars have planets. The numbers become incomprehensible. If even a tiny fraction of these planets develop life, the universe teems with it. JWST hasn't found aliens yet, but it's shown us the stage is set. The ingredients are there. The time is available. The only question is, when we'll make contact, not if. These discoveries are already changing technology here on Earth. JWST's infrared sensors push detection technology to new limits. Medical imaging, climate monitoring, and even self-driving cars benefit from innovations created for the telescope. The metamaterial coatings that protect JWST from heat are being adapted for more efficient solar panels. Quantum computers need extreme cold to function. JWST's cooling systems pioneer techniques now used in quantum computing labs. The image processing algorithms that sharpen JWST's pictures are improving MRI scans and satellite imagery. But the real revolution is in our thinking. JWST showed us the universe is stranger, older, and more alive than we imagined. Every assumption we had is under scrutiny. Every model needs revision. We're living through a paradigm shift as profound as when Copernicus said Earth orbits the Sun. So what happens next? JWST has enough fuel to operate for 20 years. It's only been active for 2. the discoveries will keep coming. More impossible galaxies, more biosignatures, more physics-breaking phenomenon. Each one chips away at our old understanding and builds something new. Pay attention to news about the TRAPPIST-1 system. JWST is conducting detailed atmospheric studies there. The results could confirm life beyond Earth. Watch for updates on early galaxy formation. Each new discovery pushes the timeline further back. Keep an eye on dark matter research. JWST might crack that mystery within the decade. The universe is not what we thought it was. It's older, stranger, and more fertile than our wildest predictions. JWST isn't just showing us pretty pictures, it's revealing the true nature of reality. And that reality is far more incredible than fiction. You're living in the most exciting time in the history of astronomy. Discoveries that would have won Nobel Prizes decades ago now happen monthly.
Our entire cosmic story is being rewritten, and you have a front row seat. The question isn't whether JWST will find something that changes everything. It already has, multiple times. The question is what earth-shattering discovery comes next.